Now coming to the next part, that is your part 5. We have already covered till now, that is your adsorption. The different types of adsorption we have seen it. Physical adsorption, chemical adsorption, the Freundlich adsorption isotherm we have seen it. We have seen the equations. We have also seen the uses or the applications of adsorption in our day-to-day life or in industries or whatever it is, we can say that. Now we are going to the next one, that is your dispersed system. Rather, I should say in one word, in simple word, we are going to start the colloidal system. That is a colloidal state of matter we are going to start. Got it? We are going to start the next one, the next part, we can say that, in this particular chapter. So, it is called dispersed system. What is dispersed system? The term dispersed system refers to a system, you can see it on the screen, in which one substance, the dispersed phase, is distributed in discrete units. Discrete means which is not visible. Throughout a second substance, the continuous phase or a vehicle. Vehicle, what is said? Because as the vehicle is moving, so continuous means it is also moving. Now each phase can exist in solid, liquid or gaseous state. Yeah, the phase can be whether the dispersed phase, got it, or the continuous phase, which is also called as a dispersion medium. You can write it down there. Got it? Dispersion medium. Clear? So it's present, that is dispersed phase and the dispersion medium can be solid, can be liquid or can be gaseous. Now in simple words, let me tell you what is dispersed phase means. It is known as solute. And what is dispersion medium means? It is known as solvent. Together it forms what? Solution. What solution? Colloidal solution. Just now I said it. Colloidal solution. Got it? In simple words, dispersed phase. But you have to use this term here. See, to make you understand, I am saying you. Now don't use a solute and the solvent here. No, you can't. Solute and the solvent is used for true solutions. But here you need to use for the solute dispersed phase and for the solvent it's a dispersion, what you can say, medium. Clear? Here you need to use that dispersed phase and the dispersion medium. You have to use. Got it? Clear? That you remember it. You cannot use any other term apart from that. We can say that. So here in case of crystalloids, got it? See, we are having different types of solutions. We will come to it now. That is different types of solutions. We are having true solution, we are having colloidal solutions, and we are having, that is nothing but known as suspension. Got it? Which is also called heterogeneous dispersion, we can say that. Suspension. Clear? Fine. Now, true solution are formed from crystalloids. What do you mean by crystalloids? Which is completely soluble in water. For example, when sugar and salt is dissolved in water, sugar and salt, they are called as crystalloids. They are known as crystalloids. They completely dissolve in water. Remember it, they completely dissolve in water. Here water is a dispersion medium and sugar or salt is the dispersed phase. Just for example, but we will not say dispersed phase and dispersion medium. Just I am giving an example. Children. Listen carefully. Here you will say water as a solvent and sugar as a solute. Just to make you understand what is dispersed phase and dispersion medium I am giving you. But here the term will be solute and the solvent only because it is a true solution. It is a crystalloid. It's a true solution, it's a crystalloid, so don't get confused. Got it? In terms of colloidal solution, again and again I am saying you, that is solute will be known as dispersed phase and solvent will be known as dispersion medium. Mind it. Got it? In case of colloidal solution, which is known as dispersion. Just now I said you can see that is dispersed systems. Clear? So in this way. Now that is a true solution. Now what I said you, that if you take sodium chloride, that is salt or sugar, and if you dissolve in water, it behaves, where sugar behaves as a crystalloid and water is a solvent simply. That is, sugar is nothing but a solute and the water is a solvent. Fine. But listen carefully now. But the same substance, that is sodium chloride or sugar, when you add in benzene, it does not dissolve. Sodium chloride sugar does not dissolve in benzene completely. Partially dissolves. Partially. I don't say that it does not dissolve at all. Partially dissolves. So hence it behaves as a colloidal solution. So what you can say, the sodium chloride when dissolved in water behaves as a crystalloid. But same sodium chloride when dissolved in benzene behaves as a colloid. We can say that. It behaves as a colloidal solution. Now, colloid means what? Colloid has come from the Greek word which means glue. Glue means gum. Sticky. Got it? Colloid has come from the Greek word which means sticky, glue, gum, like substances. They are called as colloids. We can say that. Clear? Now, substances like common salt, sugar, urea, etc., which is obtained in the crystalline form, and hence they are called as crystalloids. They pass through what you can say parchment paper, or they dissolve rapidly, diffuse rapidly, and they pass through the parchment paper membrane, you know, the animal membrane or the parchment membrane, semi-permeable membrane, so to say. Otherwise, we can say that they pass rapidly because the substance, the particle size is so small, no, that can easily pass through any kind of filter paper, any kind, remember it. But substances like starch, gum, glue, gelatin, albumin, etc., which are non-crystalline, listen, non-crystalline, previously I was saying crystalline substance, non-crystalline nature, in the dissolved state do not diffuse what you can say rapidly. They diffuse rather slowly, at a very slow rate, through the parchment membrane, through a semi-permeable membrane, through an animal membrane. So those substances are known as colloids. We can say that they are called as colloids or colloidal solution. As a result, it forms. But if the particles settle down, like suppose you have taken some chalk powder, you have taken some coal dust, you have taken some what you can say clay or mud, you have taken it, you have mixed with water, what you will find? They settle down. They are not called colloids or crystalloids. They are called as suspended particles, and such a system is called suspension. You can say that such a system is known as suspension. You can see it here, I have written there, heterogeneous dispersion, where the particle size is greater than 1000 nanometer. Which are those? Blood, milk and all those things, heterogeneous systems. Got it? They undergo coagulation or flocculation. Later on you learnt it when I will go to the properties of the colloids. Got it? Clear? And the true solution, the particle size is less than 1 nanometer, and in case of colloidal substances, the particle size ranges between 1 nanometer to 1000 nanometer. It is micro heterogeneous system like plasma, macromolecular solutions. They come under it. Got it? They come under it. We can say that. Clear? Now, in this way, you can see it here. The particle size in case of true solution already I have discussed with you, less than 1 nanometer. In case of colloidal, it is greater than 1 nanometer. It lies between 1 and 1000 nanometer. And in case of suspension, you can see the particle size. I have shown you diagrammatically. See, the particle size in case of true solution so small. Colloidal little bit bigger. And in suspension is much bigger. So they settle down. So this settle down in case of suspension. See, I have shown you the 3 types of solution here. Now, here also the 3 different colors I have shown you. Here the color is, don't think the color of the solution, colloids and suspension as such. No, just to differentiate. Got it? Just to differentiate so as to make you understand. Now, in case of solutions, true solution I mean, so that is crystalloids. It can be of single atoms, small molecules or ions or polyatomic ions. And in colloids, it's like aggregate of atoms. Means when the same smaller atoms, they come closer to each other. They form a big mass, that is aggregation of atoms, molecules or ions, or macromolecules like proteins, bigger molecules like proteins. They form colloids. Got it? So remember it, when the single atoms, molecules or ions, when they come closer, when they aggregate, got it? They mix with one another. They are nothing but known as colloids. Got it? They are called as colloids. And in suspension, it forms a lump. It clumps. Got it? It combines so that it forms a lump, a big lump. Got it? And which settles down like minerals, grains such as sand and all those things we can say. Just now I told you, na? Chalk powder, charcoal powder, sand, clay, mud and all these things. When they settle down, for example, now you can say in your house, you are getting, you might be getting, that is dirty water which is being supplied. Got it? You might be getting. Got it? You might be. So you take that particular dirty water in a glass. Got it? And you allow it to just keep it undisturbed for some time. You will see that whatever the sediments are there, the mud is there, the dirt is there, the sand is there, the mineral grains are there, that it settles down at the bottom. You will see as a sediment it settles down. What is that known as? That is called a suspension. That solution is called as a suspension. Got it? But in colloids you will find it's floating. Now the example of colloidal solution I can give it to you. That is, suppose a starch solution, example of colloidal solution. If you have not seen a starch, you will say, I don't know what is starch. Okay, fine. You can see in the winter season, the sunlight which penetrates into your house through the doors or through the windows or through the ventilators. You can see the dust particles is floating there. What is that known as? That is called as a colloidal solution. That is known as a colloidal solution. Got it? So, that is when Thomas Graham gave the definition of colloidal solution, he said it is a gum like, glue like, sticky. But later on, the definition of colloids changed. The Graham's classification of substances into crystalloids and colloids were soon proved to be wrong. It is changed. The idea changed. Alright, it was found that a crystalloids also behaves as a colloid under different set of conditions. I gave you an example that if you take salt and dissolve in water, it is a crystalloid, where water is a solvent and salt is a solute. But when you dissolve in benzene or toluene, it does not dissolve completely. It partially dissolves. So there it acts as a dispersed phase and dispersant medium. The salt is a dispersed phase and benzene is a dispersant medium. Got it? So hence, don't think all gum, glue, sticky substances are colloids. Might be or might not be also. It is not necessary. Got it? Clear? So the idea of colloids or the definition of colloids has changed what it was given by Thomas Graham. Got it? It has been changed. It has gone a large change, we can say that. Now we compare it with the help of the particle size and all those things. So colloidal state of matter is therefore a state in which the size of the particle is such that is between 1 nanometer to 1000 nanometer, that they can pass through filter paper but not through animal or vegetable membrane. I said the parchment paper, it cannot pass through semi-permeable, but it can pass through the ordinary, what you can say, filter paper. Now here you can see the difference between true solution, suspension and colloidal solution is given in terms of particle size, which I have discussed. In terms of sedimentation, colloidal solution do not settle. True solution also does not settle. Suppose if you add sugar or salt to water, will you find after some time the sugar and salt will settle? No, rather you cannot see through a powerful microscope also. The particle size is so small, it is less than 1 nanometer. You cannot see it also. So there is no question of any settling down. So true solution does not settle, but suspension settle down. Definitely. Sand, clay, mud, they settle down. Diffusion, true solution diffuses quickly. Just now I discussed with you. But suspension, they do not diffuse. They settle down. They remain as a residue on the filter paper. And colloidal solution, it diffuses slowly. If you see a true solution, it forms a transparent. So it is what you can say, particles, for that reason it is invisible. I said you just now the particle size is less than 1 nanometer. How you will see it? You cannot see it through a powerful microscope also. So the particles are not visible. It's invisible. But particles are visible when the naked eye or under microscope. In case of suspension, definitely it can be visible. Sand, clay, are you not able to see it? Definitely you are able to see it. But in case of colloidal solution, listen carefully, the particles scatter light. When it observed under a microscope, it scatters the light. In case of true solution, the light passes simply. For example, you take a beaker containing sugar solution. You allow the light to pass through it. You will see the light passes thoroughly. Simply it will passes through because it is transparent, clear. But in case of what you can say starch solution, in case of gelatin solution, in case of sodium thiosulfate solution, which is a colloidal solution, you will see the light gets scattered. The best example I gave you to the light, the sunlight which penetrates through the doors, windows or ventilators. What you have seen it there? You have seen it or not? The light gets scattered. For that reason only you are able to see the particles which is floating there. The light is getting scattered there. Now in case of true solution, it can pass through any animal membrane filter paper because particle size is very small, so it can pass through. But in suspension, it will remain as a residue on the filter paper, any type of. And in colloidal solution, it will pass through filter paper but not through animal membrane. Got it? Clear? I have said you. Then transparent, opaque and translucent we have discussed. Now that is the physical state of dispersed phase and dispersant medium. I have already discussed with you. The nature of interactions, the types of particles I have discussed. Now based upon what you can say, this classification of colloids, when you come based upon the dispersed phase and dispersant medium, the colloids are of different types. You can see this particular chart. So here I am discussing based upon the physical state of dispersed phase and dispersant medium. The classifying the colloids, I am classifying here, but based upon dispersed phase and dispersant medium. What is that? We are having solid sol. Example is your colored glass, gemstones, the costly stone which you are using in your that is ring, we can say they are colloids. Ruby, emerald, they are colloids. Solid liquid, that is known as simply SOL. SOL means what? Colloidal solution. SOL. Listen to the spelling. See the spelling, not SOLE. Got it? Nor SOUL. No, not at all. SOL. So paint, cell, fluids in this way. Solid, gas, aerosol. So you can go through it, this particular chart. I am not just have to read it out, this particular one, but it's very important. Very important here. You will be getting the short questions here. That if suppose the dispersion medium is liquid and the dispersed phase is a gas, then what is the type of colloid known as? It is foam. Example, your soap, leather, froth, that is your shaving cream and all those things, they come under it. Clear? So hence you go through this particular chart is important, because it is given the type of colloids in the basis of physical state of the dispersed phase and the dispersion medium. So you will be getting the short questions upon it. Like solid gas, dispersed phase is solid and dispersion medium is a gas. It is known as what? Aerosol. So what is that example? Smoke, dust and all those things. So here one thing I remembered, let me just tell you, that if the dispersion medium is water, listen carefully, it is known as, the type of sol is known as aquasol or hydrosol. You may write it down. If the dispersion medium is alcohol, then the type of colloidal solution is called alkosol. If the dispersion medium is benzene, it is known as benzosol. If the dispersion medium is gases, like here you can see, dispersion medium is a gas, it is called as aerosol. Example is smoke, dust and all these things. Clear? So this chart you go through it, it's important. Now next, coming to lyophilic and lyophobic colloids. Lyophilic means what? The word you break it up. Lyo means liquid. Got it? Philic means loving. So liquid loving colloids are called as lyophilic. Liquid loving, which loves the solvent, which loves the liquid, which loves the dispersion medium, that is called lyophilic colloids. Substances like gum, gelatin, starch, etc., which when mixed with a suitable liquid as the dispersion medium directly form the colloidal solution. Simply you are mixing it up. For example, you want to make a starch solution. What you will do? You will take water, dispersion medium, that's a liquid. You add starch. You will see it easily dissolves in it. Dissolves, I am saying, it easily forms a colloidal solution in it. Easily. Nothing you have to do. Just to stir it a little bit. That's it. Easily, directly, we can make a colloidal solution. So that is called as lyophilic colloids, lyophilic sols. But there are also lyophobic. Phobic means what? Hating. Liquid hating. When I say lyophobic, lyo means liquid. Liquid hating colloids means do not have any affinity for the solvent. They do not love the solvent, do not love the dispersion medium. They are called as lyophobic colloids, lyophobic sols. The substances like metals, their sulfides, etc., which do not simply mix with the dispersion medium, got it, and form colloidal solution. They have got some special methods of preparations, got it, to prepare these colloids. We learn some special method. In the next, we will see the special methods are there. So such substances are called lyophobic colloids or lyophobic sols. Liquid loving, lyophilic. Liquid hating, lyophobic. Liquid loving colloids can be prepared by simple methods, got it, directly. But liquid hating colloids cannot be prepared by simple methods. They have got some special techniques, some special methods of preparation, we can say that. Got it? Clear? So in this way, we are having what you can say lyophilic and lyophobic colloids. Lyophilic colloids is also known as intrinsic colloids. Lyophobic colloids is also called extrinsic colloids. Lyophilic colloids is reversible colloids, it's a reversible sol, got it, but lyophobic is irreversible in nature. Reversible means, that is, what you find is that suppose when you mix it, this particular, suppose you are mixing that is your starch and water, got it. So what do you do? Just to simply shake it, that is, you can mix it. So they are reversible in nature, we can say that these are reversible. So hence they are known as because these sols are quite stable and cannot be easily precipitated. So hence they are reversible, got it. But the other one, the lyophobic, they are not easily precipitated, got it. They are irreversible in nature, we can say. Clear? And they cannot be prepared with simple methods, I should say, got it. Now next is the lyophilic are easily hydrated. They are highly hydrated, but they are not much hydrated because they do not have affinity for the solvent, so they are not hydrated at all. Got it? Then the nature of the substance is, I told you the lyophilic colloids is starch, gum, proteins, etc. They generally form lyophilic colloids. But metals and the sulfides forms lyophobic colloids. Lyophilic colloids have viscosity much higher than that of the medium. But lyophobic colloids have viscosity same as that of the medium. Medium means the dispersion medium. Got it? The solvent. Then lyophilic colloid, the surface tension is usually lower than that of the dispersion medium. But in case of lyophobic colloid, the surface tension is nearly the same as that of the dispersion medium. Alright, so these are the difference between lyophilic and lyophobic, we can say that. Now coming to the types of colloids, that is another types on the basis of the types of particles. Basically we have got multimolecular, macromolecular and associated colloids. Multimolecular, understand the word. When on dispersion of a substance in the dispersion medium, a large number of atoms or smaller molecules of the substance whose diameter is less than 1 nanometer, that means the crystalloids, when they come together, they aggregate together, got it, in the dispersion medium, the smaller atoms, the smaller molecules, they come together, they aggregate together, got it, to form a species having size in the colloidal range. That means the particle size whose size is less than 1 nanometer, you know they are crystalloids. They come closer. When they will come closer, the particle size is going to increase. It will become more than 1 nanometer. So when they will reach the colloidal range, then that particular kind of colloids is called multimolecular colloids. Initially it is less than 1 nanometer. They will aggregate, they will collide, they will come together. But in the dispersion medium, the smaller molecules forms a bigger molecules, a larger molecules, and hence when they reach the colloidal range, that particular colloid is called multimolecular colloids. Example is a gold sol, got it, having several atoms. Got it? A sulfur sol having several atoms, thousands of atoms are there. When they come together, they form what you can say, nothing but gold sol, gold atoms, that is crystalloids. But when they come together, got it, in a given solvent, they come together and they form a gold sol, that is they form a multimolecular colloid. Similarly, sulfur atoms, they come together and they form a sulfur sol, we can say, in a particular solvent. Now why they will come together? Because they are held together by weak van der Waals forces. When they come together, they are held together by weak van der Waals forces. So in case of multimolecular colloids, the force which is responsible to hold the two or more atoms together to form a multimolecular colloids is your van der Waals forces. I hope you understood this. Macromolecular colloids. When certain substances having big size molecules called macromolecules having larger molecular masses are dissolved in a suitable liquid, they form a solution in which the molecules of the substance, that is the dispersed particles, have the size in the colloidal range. So when they are dissolved in a solution, when they are put in a solution, then the molecules, the macromolecules, they break up. Got it? They break up and they are having the size, they are having the particular size in that of the colloidal range. Got it? So that is nothing but known as macromolecular colloids. Got it? Big size molecules, they are already big. In case of micro, they combine. Multimolecular, sorry, they combine. The smaller they combine and become a bigger. Here already it is big size molecules. They are already macromolecules. They are having large molecular masses. When they are dissolved in suitable liquid, when they are put in a suitable liquid, in a suitable solvent, in a suitable dispersion medium, they form a solution of the molecules of the substance. If it is needed to break up, they break up also. Got it? And they give rise to a colloidal range. The particles comes in a colloidal range. So that sort of colloids is called as macromolecular colloids. Example is polymers with high molecular masses like starch, cellulose, protein, enzymes, they are. Got it? If you say some artificial polymers like your polythene, nylon, polystyrene, synthetic rubber, you will be studying about it in the biomolecule chapter in the polymers and polymerization in details about it. So these substances, starch, cellulose or polythene, nylon, they are known as macromolecular colloids because already the particle size is big, already they are large molecules, already the dimension is bigger, already they have got high molecular masses. They come in the colloidal range and they become stable. Got it? So that particular colloid is called as macromolecular colloids, we can say that. Then associated colloids or micelles, we can say. The substances which are dissolved in medium at a low concentration behave as a normal or strong electrolyte at a low concentration when any substance is dissolved. But at higher concentration, it exhibits a colloidal properties. So remember that associated colloids at a higher concentration behaves as a associated colloids only at a higher concentration because they have the colloidal set of properties. But at lower concentration, it is a normal electrolyte. It's a normal electrolyte, we can say that. For example, sodium chloride. In low concentration, it's a normal electrolyte, dilute NaCl, we can say that. But concentrated one in case of benzene, in benzene solution, in benzene solvent, they behaves as a colloidal particles. Because In case of benzene, the sodium chloride molecules, they come closer again. They form an aggregated particles, which is called as associated. The name itself, it's association, means definitely association, how it is formed. A group of people when they come for a cause, that is called association. See, also same thing. When the, what you can say, dispersed phase or the solute, what you can say that, they come closer in a given solvent at a higher concentration. Got it? They form an associated colloids, which is known as micelles. The aggregated particle thus formed are called as micelles. It is known as micelles, we can say that. So here I have given you the difference between the multimolecular, macromolecular and associated colloids, so to say. Now listen here, in case of micelles, the formation of micelle takes place only above a particular temperature, and that particular temperature is called as Kraft temperature, and only above a particular concentration, which is called as critical micelle concentration. Remember these two terms, Kraft temperature, KRAFT, not CRAFT, KRAFT, a scientist was there. Got it? So which is represented with letter TK, capital T, subscript is small k. That is called Kraft temperature. The formation of micelles or associated colloids takes place only above a particular temperature, that is called Kraft temperature, and above a particular concentration, that is called critical micelle concentration, or CMC, we can say critical micelle concentration. Got it? Now you will be studying about the micelles later on also. That is the form, that is for the soaps. You know the critical what you can say concentration is nothing but 10 to the power minus 4 to 10 to the power minus 3 moles per liter, CMCs, for soaps. So for the soap and the detergents, where 100 molecules, they come closer and it forms a associated colloids, or micelle formation takes place, we can say that. Clear? So micelle formation takes place above a particular temperature, that is called as Kraft temperature, and above a particular concentration, that is called critical micelle concentration, so to say. So this is all about